Good morning, people. This is Kali, and today we're going to be talking about this hydrodynamic model because I was just thinking about it a little bit recently. So the concept is that we live in a space that's full of a fluid called space, and it's a dielectric fluid, right? Which means that charge actually does not carry through this at all. Charge gets localized, extremely localized, right? Charge can't pass through space very well at all. Okay. In a way, it's a dielectric fluid. Yes. So if you have a wire, okay, and you can put up a high voltage on that wire, and the charge will not be. The electric field will be detected, but the charge can't be carried by anything. It stays local. It's a dielectric fluid. But a flow in a dielectric fluid, if you have a dielectric fluid and you cause a flow in this dielectric fluid, you cause what's called charge separation, which means that this used to be right next to this, and they were happy together. Right? But then you pulled this one person away from their friend, and so they're upset, and so they make a voltage differential that's larger. Now, you multiply what was the charge differential by the length that you stretched that distance by, and you have increased the voltage. This is the principle by which Van de Graaff generators work. It's really like insanely interesting principle, actually, that you can drag a charge and you increase the charge by just causing a wider separation of charge. If you have two plates and you start to pull them apart, there's a tension. Those plates want to be together. They don't want to be apart. There's an electric tension that builds and builds and builds, and usually you'll just get an arc, or it will dissipate into the air, right? There's like this charge that wants to be settled. The air will take the charges away. But actually, we need to do that in a crazy vacuum. That would be a way of getting insane charges, I think, very easily. A physical separation method like that. Anyways, so this is what happens. Which increases the voltage, so it wants to pull back. Plus, you've increased the field, so we'll talk about that too. So, gravity. We have a thing. Another thing. These are parallel paths, pretend. These are perfectly parallel paths, right? So you have some current, and this applies to everything because this is sort of a gravity thing. This is gravity attracts things, right? Mass accumulates. This is the nature of gravity. Gravity gathers things. Okay, I know it sounds really, really simplistic, but sort of it is. You can describe it in fancy ways. Okay, so there we've got our field. We've got a similar field here, right, because they're the same. Okay, so notice that at this point, why do things gather? Why does everything gather? Because of chirality of the universe, maybe. Okay, so at this point, this arrow is coming forward, right? It's about to go around like that, so it's coming towards us. So it's a classic nomenclature. Okay, and this one is going away from us. Which means that here along here, we have extra low pressure because this is coming this direction, and we have twice the velocity at this interface seam that we do other places because it's interacting like relative here is relative there. This is moving past at speed. Sum is double. So you have low pressure, which brings these things together. Okay, and the solution, the optimized solution for this, because then you push against each other, and the optimized solution for that is the twining. And I'm going to do a thing on twining, but you have it come, you have it go like this. And because this is getting pulled in, this goes like this wraps around the back, and you have twining. And this is why you have plasmatic, like double stranding. It's sort of innate. And when you have these two things going the same direction, the field interaction is such that it binds them together. Okay, now more generally, hydrodynamic to minima. So, if space is a fluid, a self-exciting fluid in that it spontaneously densifies, which it seems to, and we'll just apply this everywhere because E equals mc squared, and therefore we're going to apply the same logic to the fluid of space as we are to mass objects, which have very particular granular characteristics. But we're not. We're going to treat it as space. Okay, so there's EO and UO, which basically describes the fact. What we end up with is the Planck, which is the minimum turn radius that you can make in space. You can't turn a sharp corner in space, right? You've got to have some turning radius, and that turning radius is the Planck. Because once you get going so fast, you start to curl, and the curl will be around a Planck. This is our minimum turning radius. Then you're in orbit around yourself, and you're a little singularity orbiting yourself, because this is the place you can't go, is the middle of the Planck. Okay, so imagining, as I do, underneath the universe there's this membrane. It's 1 Planck second in dimension. All different points share this dimension. They're all on the same plane. It's like this similar to computational model where this is the present calculation. Okay, this is a softer version because it's not rigid, it's a rotation. It's continuous flow rather than chunk, but same idea. There's this continuous moment of what is going on right now, what is happening, and there's you have this much time, Planck second. It's actually 360 degrees. You can't do that in, what looks like 180 here is actually 360 in real world, because I can't show 360 really very well, and also have another 360 on the back end of it. And that links to this whole octonions and quaternions thing, because if you have a membrane, right, you have a sphere here, you have a sphere here, and you move the sphere this way, and so you move the sphere this way. Right? It's like the gear interlocked all the time, and therefore they're reciprocating, only it's is that actually right? It should be though. And if this rotates, but this rotates clockwise, is actually looking down, rotating counterclockwise, if it's going the same way. So yes, so you have these interlinked matter-antimatter worlds, and once in a while you can flip it over with a lot of energy. The essential things is if everything's going around a Planck, so we'd have, which are the different rotations we can have? Right? So, we could go like this, right? Which would be basically like somehow would be an inflow in one part over here. This was going up and this going up, right? Inflow, which would be an outflow on this side in the antimatter universe. Oh, nice. Conservation. And then this would go like this, but this should make it a positive charge over here, which is maybe why charges always have to balance. And you could have maybe a bunch of aggregate inflows somehow, because these don't have to be spinning. It's just, this is the minimum turn. So what are the movements you can make? You can turn this way creating inflows and outflows, right? Or you can turn if you turned like this, it's not even rotating around this axis anymore, right? This is usual flow. Here's an electron or positron. This is a neutrino. Right, because the only movements you can have are inflow, outflow, curl one way, and curl the other. In the end, all around this Planck length. These are your modes of action, and this actually probably links with that woman with constructionist, because that's what it is. It's functionalism. It's like, let's get down to what is possible to happen. Okay, so you can have things spinning in one of two directions, and you can have things flowing in or out. Basically, that's all you get to do on a membrane like this. And if that's the way the universe is, which it seems like it is, then this is what we're limited to. But look at, we've got electrons, we've got positrons. If we put a charge with a spin, right, now we have a vortex, because not only is it spinning rotationally, but it's also spinning rotationally, oops, that way. Okay, so now we have, and that's now self-supporting and constricting. This motion tightens this, which tightens that. Okay, self-supporting, interlinked, like hypervortex thing. Okay, but seriously, it makes perfect sense. This is an inflow and outflow, and this is a rotation. But consider, and I just thought of this the other day. So let's say you have a neutron, and pretend a neutron is a mass photon orbiting another mass photon. Right? This is the one, this first one is going to be the mass unit that never disappears. This is the one that will stay with the proton when this photon decomposes, the second photon. So, when this decomposes, this is moving at the speed of light, right? And it has that orient chirality. Oops. Sorry about that again. Very unprofessional. This has a chirality because of the universe. A neutrino comes by that's spinning the same way. And what can it do? It can't do anything. It's like, what's it going to do? Add to the momentum of this. It's already going the speed of light. Okay, you can't speed this up anymore. It's already maximized out. So really, it's got no interaction. It's got nowhere to go. But if you're a neutrino that's spinning, so this is spinning this way. If you're a neutrino that's spinning this way, and you're spinning at the speed of light, only you're flopping around in all kinds of different directions, but still. This interacts with this. Sum 0. All of a sudden, this photon gets stuck dead in its tracks, and it becomes charge. Actually, this is why neutrinos are the charge on and charge off particles. Okay, because imagine you're an electron now. Wait. So you're a hydrogen atom. We decomposed this photon. We turned it into the electric charges on this hydrogen atom. Right, there's the proton. Mass unit with positive charge. Out here is negative charge everywhere. Okay, but you come along and a neutrino comes and it's spinning the right way and it like interacts with this proton and spins the charge onto, though I suspect actually these are up in opposite rotations just to balance things out, no doubt. So I'm going to have to go through the neutrino math in detail. But, so this is spinning this way. Oh yeah, that's perfect. Oh no. Probably want to go in synchrony. Because then you just charge bound together. And basically it's two charges exactly in... Yeah. But you'd be phase out of relationship, right? Same direction, out of phase. Boof. There we go. Now we've got a neutron again. Because the neutrino was spinning the same way as this was, so it could spin the electron onto it. But if it comes to a neutron, I know it was the other way around. We'll work this out. But just functionality-wise, like, how simple is that? The spin counters the spin, negates the spin. All you have now is still charge, radial charge, positive and negative. It's not rotational anymore because these two velocities countered each other. Crazy, right? But this is the thing, the minima. What's an electron is the minima. Like, let's say there's a bunch of those spheres. We're going to see it from the top. Bunch of those spheres, all of them going out, right? So now we have a little pocket of inflow. You know, there, an electron. And nearby, this would be bound to some, I mean, it doesn't have to be singular like that. It can be groups, it can be flows, it's clusters. You know, it's a fluid. It's just that that's the minimum at, there's always going to be like that little point. In terms of the functionality, though, of neutrinos, I really think that's like major insight. And I need to talk to that constructivist woman. Okay, peace out. More ramblings, but if you're paying attention, I think that's actually like quite interesting.